this rational function, we're going to follow the exact same procedures we've been following, but something strange is going to happen with the horizontal asymptote that we want to look at, and it ends up being a slanted or oblique asymptote. But let's start with our favorite guy, the vertical asymptote, because everyone knows vertical asymptotes is where the graph can't go, and we find them by figuring out what makes a function divide by 0. Because that's the thing, you can't divide by 0. And so we want to make sure the graph doesn't touch any x value that might make you divide by 0. So I look at the function, I can see x plus 2 is in the denominator, so if x happened to equal -2, that would be a problem. So I want to make a line, a vertical line through -2, a brick wall, so that the graph does never, ever, ever touch this place. As the graph approaches -2, it'll veer up or veer down. When you write what the vertical asymptote is, you can't just say -2. It has to be the equation of a vertical line. So a vertical line has the equation x equals whatever that is. Now I'll do my analysis for a horizontal asymptote. That means what's the graph going to do when x gets very far away from 0? So very, very, very big or very, very, very negative. For very, very large numbers, this term in that polynomial takes over, and this term in that polynomial takes over. So I can look at the expression 2x squared over x. That's what this will behave like for large x's. This can be simplified to simply 2x, and the problem is, as x gets larger and larger, this also gets larger and larger. As it gets more and more negative, this gets more and more negative without bound, but it is linear. It's a straight line. It's like an mx plus b. So we want to figure out what that straight line is. We like straight lines. They're easy. So if we can, we're going to figure out what that straight line is. And to figure out what that straight line is, I'm going to take the original function and carry out the implied operation of division. You know, if I have something written over something else, we're supposed to do division. So I'll use synthetic division. Setting that up, I have a 2 and an 8 and a 6, and we're dividing by x plus 2. So I'll put a -2 out here, drop this down, multiply those together to get -4, add these to get 4, multiply these to get -8, remainder is -2. And what you may not know is what we're saying is this function divided by this function equals 2x plus 4 with the remainder of -2, or with -2 over the divisor. And for super duper large x's, for x's that are very, very far from 0, 2 over very, very large is very, very small. This whole part goes to 0 for big x's. We can ignore this. So essentially what we're saying is, for very large x's, this function will behave essentially like this function. And I'm going to graph that function using my awesome Algebra 1 skills that I learned goodness knows when, long time ago. So if you can almost picture that as if it were a horizontal asymptote that like fell over, that can be very beneficial. I don't know if you can see what I'm doing here, but like let's pretend like I had an asymptote here, but it went like, and it like got tilted. Everything else is the same. If I want to find the x-intercepts, I need to figure out what makes that numerator 0. That'll be easiest to find if it's in factored form. I can see that's happening at -3 and at -1. I don't need to write that as an ordered pair, but I can if I want to. And then the y-intercept is what would happen if x happened to equal 0. Were I to plug in 0 for x, this is all that would be left, and that would equal 3. And these are all the clues that I have. I have the vertical line breaking the grid into 1, 2 regions. In each region, I've got to determine where the graph is in relationship to the asymptote. And in this case, it's relatively friendly. I know I've got to hit this point. I know I've got to approach this gray line. And as I get closer to this asymptote, I'm either veering up or veering down. So if I'm having to approach this line, and I'm having to hit this point, seems like the thing that would make the most sense is to go like this. And I've covered this section of graph. Now in this section of graph, similar situation, I've got to go through this point. As I approach this line, I've either got to veer up or veer down, and I've got to approach this asymptote. So if I'm going to approach this asymptote, I'm going to be going like this, which means as I approach this line, I'm going to be going down, 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 down. And that's it. It's literally the same idea as a horizontal asymptote, but the asymptote just got a little tilted. And to find that tilt, we're going to carry out the synthetic division. That synthetic division will give us the equation of a line, and that's the line that we're going to use. I hope you enjoyed this. Good luck. Don't overthink it.